Monday, April 25th. April 25th, everyone. Okay, so let's just get straight to it. Science news reviews. Oh, so we have the Fermi paradox with Neil deGrasse Tyson, part 2. He says the dumbest things. He's so hilarious. Max Egan's, okay, that's journalism. Journalism, by the way, has been around since the Flat Earth, Sphere Earth group, the very first one got big. He came out of there. He was one of the first ones in there. They started going out and doing experiments. Well, pretty much everyone was. That's why they removed. That's why this whole censorship that big tech has been doing, that Elon Musk of all people is supposedly combating or fighting, or however you want to say it. Yeah, it's all about freedom of speech and all that. I've been explaining to everyone what's going on, and freedom of speech is definitely important. I've explained that over and over. Russia, Ukraine. Oh, one day ago, space explorer NASA invents. Okay, let's check this out. Some stupid cartoons, yo.
The Fermi Gamma-ray Space Telescope is a NASA spacecraft. It is in space, researching the universe's most intense radiation producers. Radiation is defined as energy in the form of light or traveling particles smaller than atoms. Gamma rays are the most severe form of radiation. There are many distinct types of light energy. Humans can only see a tiny part of the various forms of light. The electromagnetic...
I've explained that over and over. I even have gone on to say that, light is actually sound that your eyes can hear.
Magnetic spectrum includes this light. The spectrum encompasses all electromagnetic radiation found on Earth and probably elsewhere in the universe. Electromagnetic or EM radiation travels in waves, with varying wavelengths for each type. Medium-length waves make up visible light, which is the light that individuals can see. The longest wavelengths are found in radio waves. In addition to being longer than visible light waves, microwaves and infrared light waves are also lengthier. The wavelengths of ultraviolet or UV rays, X-rays, and gamma rays are smaller than visible light. The more power the radiation processes, the shorter the wavelength, because gamma rays have the shortest wavelengths.
Okay, when they say that over and over, what they're saying is you can't take a picture of it. You cannot take a picture of any of that because even if it was a particle, what they keep claiming and all that, you would not be able to take a picture of it because it's smaller than the wavelengths of visible light. It's ridiculous. Like there's no real video of atoms and all that other stuff. Most of that, and most of that is you'll see they'll be like, no, what we're seeing is the interaction around it, and that's how we know it's there. And so it's funny when they say that.
They have the greatest energy. In this video, we'll be discussing the first space-time continuum captured by NASA's new telescope. The intensity of gamma rays is more than 1 million times that of visible light. Gamma ray...
Oh God, did he just say that? The space-time continuum. That's a concept. It's not a thing. It's not something you could reach out and touch or grab.
Have such a high level of energy that they could cause harm to anyone on Earth. The Earth's atmosphere shields people from gamma radiation. Gamma rays are absorbed by the atmosphere, which prevents them from harming life on Earth. Researchers employ satellites in space to
Do you guys see that shit? There's like we're in an ocean or something, and there's a current flow flowing around us, and then we're in a bubble that's inside of another bubble that's holding a globe. A blue marble. Oh, God. Wow, that is stupid. And it takes cartoons to try to describe this crap.
Investigate gamma rays since they can't penetrate Earth's atmosphere. Gamma rays are emitted from the furthest reaches of the universe. Researchers are exploring them to discover more about the high-energy conditions that produce gamma rays in the cosmos. Black holes and exploding stars are familiar sources of gamma rays. The space around objects embedded inside galaxies and how gamma rays emitted by these objects heavily influence these galaxies' form. NASA can better explain how the rules of physics work in the harsh settings encountered in the distant universe by researching gamma rays. Fermi was launched on June the 11th, 2008. Researchers hope to explore the high-energy universe with the telescope until 2018. GLAST was Fermi's initial name. Gamma Ray Large Area Space Telescope was the acronym for GLAST. GLAST was renamed after researcher Enrico Fermi after it was launched and started working. Enrico Fermi was a physicist who researched matter, forces, power, and motion. Physicists are scientists who study physics. Enrico Fermi was a physicist who specialized in high-energy...
Okay, so theoretical physicists are not really scientists. They're not. They don't actually. They don't do science experiments. They really don't. Theoretical physicists literally sit around and play make believe, and doodle. They doodle away, and then they make up these like weird factors, and then they mix it with Pythagoreanism. I've already explained what Pythagoreanism is. It's when you start talking to numbers and numbers start talking back to you.
Physics, especially gamma rays. NASA uses the Fermi Telescope to understand more about Enrico Fermi's theories. NASA makes nearly daily findings with the Fermi Telescope. For example, new supermassive black holes are discovered by Fermi. Black holes of this size are the most...
What the hell was that? That CGI was crap. What are they? Honestly, they can't see a black hole. They can't. I don't get. Doesn't matter what they say. Like this is ridiculous. They keep like the black holes and then spaghettification. We're gonna go next to that because this is too stupid.
Fermi is also on the lookout for new pulsars. Pulsars are collapsed stars that generate energy pulses in a repetitive pattern. Fermi discovers pulsars that can only be discovered through gamma ray measurements. Fascinating findings made by Fermi.
Look at that flat disk, yo, eating up that globe. It's turning into a flat disc and it's like eating up a spherical body. Holy crap, it's so hilarious.
Are yet to come. Gravitational waves are ripples or disruptions in the curvature of space-time.
Show me your ripples, dude. Oh, wow. I remember when they said that, the Large Hadron Collider, or, oh, no. I forgot, what's the name of it? I know it's at CERN, but there's another name for it. CERN is the laboratory, but the ring itself. So supposedly, these ripples went through the globe Earth, and they were showing this cartoon. That that said, yeah, what happened is the lasers were affected by the ripples, and they're like and then they show a cartoon of the globus Earth wobbling, like literally like Jello. I was like, what the hell are they talking about? I didn't feel no goddamn ripple.
By accelerating masses propagating at waves and the speed of light outward from their origin. They were first hypothesized by Oliver Heaviside in 1893, followed by...
And I've mentioned Heaviside many times. You guys should look him up. We shouldn't actually be idolizing idiots like Isaac Newton and thieves. Idolizing thieves like Einstein. Heaviside was one of the greats.
Henry Poincare in 1905, and then Albert Einstein forecasted them in 1916 using his general theory of relativity. Later on, he rejected gravitational waves. Gravitational waves carry energy in the form of gravitation.
Thank you, because I was about to say that. He didn't believe in gravity waves. See, that's the problem with all of this. Like, you could literally, like, it's biblical crap. You could see that they're saying is the water's above. And it's funny that the globe has like argue with flat earthers so much. And when I mean flat earthers, I mean the religious flat earthers. There's a hardcore religious flat earth movement, and when they follow the dome, and they're saying that we're protected from the waters above, like the biblical scriptures say. But if you look at this cartoon and you stop listening to their mumbo jumbo and their babbling, and just look at the cartoon and study it, you see what they're trying to implicate, or what they're trying to get you to assume that it's they use all these other words, but you look at this cartoon. Those gravity waves are literally ripples. They call it ripples. That's what happens in a pond of water. That's what happens in watery substances.
Radiation, which is a type of radiant energy akin to electromagnetic radiation. Newton's law of universal gravitation, which is part of classical mechanics, does not account for their existence because it is based on the assumption that physical interactions propagate instantly at infinite speed.
Oh, God. Come on, Globus. Explain that shit. Oh, my God. That is ridiculous. And it comes on right... No. They're saying that both Albert Einstein and Isaac Newton did not believe in this gravity wave shit. And then they show you a CGI of it happening. Holy crap, dude. What the hell is wrong with this? Oh, wow. You know what? Honestly, it's making you guys dumber.
Demonstrating one of the forms that classical physics techniques fail to account for the phenomena associated with relativity. The measured orbital decay of the Hulse-Taylor binary pulsar, which resembled the decay expected by general relativity as energy is lost to gravitational radiation, provided the first indirect proof for the presence of gravitational waves. Russell A. Hulse and Joseph Houghton Taylor Jr. were awarded the Nobel Prize in Physics in 1993 for this breakthrough.
Did you guys see this? They took Albert Einstein's crap, which he said he didn't believe. He did not believe in gravitational waves, and then they were like, no, he was wrong, and this is why. Like, they're proving people wrong with their own theories, and then they expect you to have believed that theory from the very beginning. That's insanity. It's insanity. They're like, believe in this. Oh yeah, it's wrong. See, that's why you should believe and then they're like, you still should have believed in it. It's the same thing. Isaac Newton said gravity, and he said mass attracts mass, gravity. Albert Einstein was like, no, that's all wrong. It's space-time curvature affecting matter and mass. Gravity. What's to stop me from saying like, no. It's not time and space. It's not space-time. My hypothesis, and I've said it before, is timed space. Gravity.
First direct observation of gravitational waves was achieved in 2015 when the LIGO gravitational wave sensors in Livingston, Louisiana and Hanford, Washington detected signals produced by the merger of two black holes. Rainer Weiss, Kip Thorne and Barry Barish were awarded the 2017 Nobel Prize in Physics for their contributions to the detection method of gravitational waves. Observations of gravity waves are utilized by gravitational wave astronomy to deduce information about the origins of gravitational waves. Binary star systems made up of white dwarfs, neutron stars, black holes, and supernovae, and the development of the early cosmos immediately after the Big Bang are examples of sources that can be investigated in this fashion. Albert Einstein postulated the existence of gravitational waves, ripples in the fabric of space-time caused by extraordinarily powerful cosmic cataclysms in the early cosmos, over 100 years ago today. In 1916, Einstein predicted that such waves would be tiny and practically challenging to identify, based on his understanding of the universe.
See how they literally twisted his words around. He just like the same thing that Isaac Newton said. Okay, that those were beliefs that like literally like Isaac Newton said himself that the whole mass attracting mass didn't make sense, and the only reason why it would make sense is because only a God could have created something so weird. It couldn't have like there could not have been a creation point where that slowly came into play and then it just stabilized like that. It doesn't make sense. That doesn't make sense at all. That's not how physics works. There's entropy, your loss of energy, and all that. It doesn't make sense that an explosion would create perfection. Unless it's a god. Okay? Einstein said the only way this would work if some imaginary shit like gravity waves existed. But yeah, I doubt, anyone would ever find such a thing because I'm just postulating it. And then years later, they're like, oh yeah, we figured it out. And then they show you some cartoon. They're like, see? His imaginary postulation was correct. Look at this cartoon. Holy crap, dude. Dude, I'm serious. I have no reason to believe any of this. You could literally see that they're twisting his words around. What he said was, the only way this could actually exist if there was like some weird gravity wave shit. Just like Isaac Newton said, the only way this could exist if it was God. Oh wow, this is hilarious.
And the tools available at the time. Over the last century, astronomical findings and technological advancements have altered those expectations. For the first time, scientists from the LIGO scientific collaboration, which includes MIT and Caltech scientists, have directly witnessed gravitational wave ripples in equipment on Earth. As a result, they have validated Einstein's theory of general relativity once more and opened a different way of looking at the universe. But there's more. The researchers have decoded and identified the source of the gravitational wave signal. The signal was discovered using the LIGO.
Okay, they keep trying to go around what they're trying of how it supposedly works. Now these two lasers are supposedly shooting in different directions, and they're supposedly continuous. When they're saying when one of these wobbles happens, these gravity wave rippling wobbles, that rippling through the waters above, through the heavenly dark waters above, as it ripples towards us. Okay, it throws one of the lasers off from the other. oh, and it's followed by a chirp. I think they hear the chirp first. It's chirping and it chirps, and then the lasers are go a little bit off, and then they're like, "Yep, the globe wobbled."
Or Laser Interferometer Gravitational Wave Observatory twin detectors, meticulously built to detect exceedingly small vibrations from passing gravitational waves. The researchers turned a gravitational signal into audio waves and recorded the sound of two black holes spiraling together before combining into a single larger black hole.
No, it didn't record anything like that. It just what it recorded supposedly was an anomaly. They just said it right now. It's a small little vibration. That's all they recorded. If that's even true. Listen to what they're saying. Do you guys know how much this LIGO shit cost? You guys should look up how much this LIGO shit cost. All right? Look up how much this LIGO shit cost, and then I'm gonna say it's still ongoing. Okay, they're getting money for saying this crap. They get money to chase around imaginary vibrations. And then they show you a cartoon, and they're like, "Yes, two binary black stars and two non-binary, two non-binary bodies." Holy crap, dude!
The team could track the final minutes before the black holes merged by further examining the gravitational signal. They discovered that the black holes, which are 30 times as massive as our sun, ringed each other at close to the speed of light before colliding and emitting an enormous amount of energy comparable to about 3 solar masses in the form of gravitational waves.
There is no video of that happening. That's what I'm trying to say. It's not like that cartoon that we just seen right now, that CGI. It's not like, yeah, they're not even saying, okay, yeah, we sent a camera and the camera got really close to these two black holes, right? And look, here we have one black hole going towards the other black hole. Okay, here they're interacting. That's not at all what they're even trying to say that they did, that they see. All they're saying is their little stupid lasers wobbled. The rest, all that is like, oh, it could have only have this. The lasers could have only have wobbled because of the two non-binary non-binary black hole assholes are arguing in the void of nothingness. That's why. They like show you a cartoon. Wow.
As per Einstein's equation, E equals mc squared. After that, the waves...
That has nothing to do with E equals mc squared at all. That's energy equals light times speed or some shit like that. Where does that have anything to do with two black holes causing a wobble, causing a wobbling ripple across the heavenly waters above? Where? It doesn't. You know how many times Albert Einstein said he couldn't stand what they were doing to his equation? He said when he made his equation, he didn't expect for mathematicians to go out crazy with this crap, with his stolen concepts.
Reverberated throughout the universe, effectively altering the fabric of space-time, before passing past Earth more than 1 billion years later as faint vestiges of their cataclysmic origins. In 1974, physicists Russell Hulse and Joseph Taylor identified a pair of neutron stars 21,000 light-years distant from Earth that appeared to behave unusually. They determined that the stars were orbiting one another, so that energy was being lost in the form of gravitational waves, a discovery that earned them the Nobel Prize in Physics in 1993. LIGO has now achieved the first direct observation of gravitational waves using an Earth-based device. The scientists used the twin LIGO interferometers to identify gravitational waves on September the 14th, 2015. According to the latest research, telescopes that monitor the universe in the most intense forms of light may aid scientists in detecting the fingerprints of gravitational waves. When large objects collide, like black holes, gravitational waves are created, causing ripples in space-time to wash across Earth. Modern gravitational wave observatories, like the Laser Interferometer Gravitational Wave Observatory, or LIGO, and the Virgo Interferometer, can discover the violent collisions resulting in gravitational waves, but they can only witness one of those events at a time, which can be months apart. However, hunting for imprints...
See, that is totally stupid. The only thing they're proving is that they can detect small vibrations at all. That's it. With what they're saying. Like I said, I mean, it's not like they have a camera up in next to two non-binary black hole assholes. Like, no, they don't. Okay, they themselves, they have some earthbound devices that are shooting lasers, and whenever those lasers for some reason fall out of alignment, okay, that it must be because of some non-binary black holes. Holy shit. It can't be for no other reason. It has to be that. Because they said so, and they got this cartoon. Oh, and because, E equals mc squared.
Gravitational waves in pulsars, fast-spinning neutron stars that pulsate at regular intervals, could be another approach to locate them. Thanks to observations by NASA's Fermi Gamma Ray Space Telescope, which monitors the universe in gamma rays, the most intense form of light, scientists claim they have illuminated the way toward that objective in a new study.
See the edge? Look. All the way to the left, there's a creation event. As it's expanding, there's an edge. You can see the edge. Okay? And so beyond that edge, you see the black darkness. And then you see the edge of the boundaries of the image that's on the screen. Do you guys understand what I'm saying? Like, literally, okay, so... I mean, technically, that's not really your screen. The edge of your screen can't be the edge, right? So that darkness that's around that edge of the Big Bang expansion must continue on to another edge, right? Yeah. Holy shit.
Pulsars rotate at extremely exact intervals, which astronomers can track from Earth thanks to the pulsar's emitted beams. As gravity waves pass through a pulsar, they may cause minor variations in its timing, which astrophysicists believe they can detect and track back to the gravitational waves that cause them. Astronomers have
which astronomers believe, they believe in unicorns, that they could track down the unicorns across the Milky Way as they travel over the cosmic rainbow. There's a cosmic rainbow, and the unicorns are just traveling across it, and they curve. Rainbows curve because of space-time, obviously.
Additionally discovered pulsars by scouring the sky for radio waves with radio telescopes. However, the gas and dust that make up the universe are not friendly to radio waves, and many of them are absorbed along the way. On the other hand, gamma rays have the maximum energy of an electromagnetic wave. Thus, they'll pass through. However, astrophysicists had never utilized gamma rays to follow pulsars before this study. The findings could point to a new, more powerful means of detecting pulsars, and as a result, gravitational waves, with researchers hoping that further advancements would make these detection techniques even more sensitive. That's all there is for today. Thank you for taking the time to watch this video. Please leave us with your valuable feedback if you found this video interesting. Stay tuned till the next video. Until then, see you soon.
Just like that crap. It was all cartoon, all hypothetical crap. They admit that, they say what happens to their supposed earthbound device. And then, for some unknown reason, they just want to go ahead and imply also all kinds of other crap. They're like, oh yeah, because my little lasers are like, my little lasers, like those are some huge lasers. Like honestly, like they're getting paid a lot of money to play around with the fucking laser, and then make a cartoon about it after. They're like, yeah, look at this, my laser, got bumped, and so because my laser got bumped, like, look at this cartoon of the globe Earth wobbling. Holy crap. That was stupid. That is not science, guys. Come on. That is like some Star Trek movie type shit. Like, you know what I mean? Like, honestly, that was like totally nonsense. There's no way of us confirming their claim at all. There's no way of us to replicate or reproduce, and that's what science. That's what science is about. Okay, when you talk about I have an experiment. That experiment, first of all, for it to be scientifically sound, all right, must be replicable and be able to produce reproducibility. Okay? I should be able to say this is how I did the science experiment. Matter of fact, let's back out. Cavendish. Let's go to the Cavendish experiment. And I'll explain what I'm trying to say. Okay. I read how Cavendish did his experiment. All right, I literally read it. I mean, he built the torsion contraption all his own. He used a full lead ball. Like those were some heavy balls, and they had to be perfect. And so, okay.
I've still seen a small amount of motion here. So
okay, so this is not the Cavendish experiment. All right, first and foremost, the staging area has not been prepared as Cavendish supposedly prepared his staging area. All right, as we see in this here, and let's try to, okay. So this little fake contraption that they have going right there is not the Cavendish torsion contraption that he built. Next, okay, it is not isolated from other potential mass. Right? Third, he's too close to it. Or fourth, you know what? Let's just go off it right off the top. Right off the top, all right? He himself is standing next to this torsion contraption. He himself is a body of mass and matter. Okay? What he just did right here, and his fake wannabe Cavendish crap, which he totally destroyed, okay? His mass and his own body mass and his own matter should be affecting this fake torsion contraption crap that he made. And it's obviously not. The reason why Cavendish built his that enclosure, it was a large enclosure, really huge, over 6 feet tall. And then he put a hole in it. And then from like 100 yards, he studied it through the hole with a telescope for months in a row. Okay? His staging area was isolated to make sure nothing else could possibly be causing the mass. The movement, I mean. Because you guys are claiming it's the mass. It's the mass. You guys keep saying that. As we can see right here, this idiot is in the classroom standing next to this contraption. His mass has not been accounted for. And nothing is moving towards him. On top of that, if it's a classroom, it's full of electromagnetic interference. You got Coulomb's law, electrostatic, dielectric potential. Like, the list goes on and on. Your heartbeat should be affecting this experiment that he's trying. He totally just, that's not what Cavendish did. That is not what Cavendish did at all. He didn't stand in a classroom. He didn't use bowling balls. He didn't use this fake stick and a brick. He didn't use this, like this, a big sphere while he's standing. No, he used a hardcore lead ball. Okay, this right here, this video from 10 years ago, he explains that you can't do the Cavendish experiment. None of this is the Cavendish experiment. None of it. Like I said, Cavendish built an enclosure for the torsion contraption, which was huge. The torsion contraption ball itself, the lead ball, was like 33 pounds or 50 pounds. I forgot how heavy the lead ball was. He used specific material. He wrote down the dimensions of of not only the torsion contraption, but also of the enclosure. Okay? And then, like I said, he built all of this in the middle of a field where nothing else could possibly be. Like, he cleared it out. It was literally an empty field, so you could see through a hole and monitor everything through a hole with a telescope. All right? Don't tell me you did the Cavendish experiment unless you actually replicated how he said to do it and reproduced the same results. All right? Because as of now, this idiot right here in this classroom is standing next to this fake wannabe Cavendish torsion contraption. That's not the torsion contraption there. That's not. All right? He's standing next to it. How can his body not affect it? That's mass. What's even funnier is when they do this in a classroom full of students and all the students are on the same side of the classroom. And the stupid thing doesn't move towards them. Okay? Don't tell me you did the Cavendish experiment, all right? You did not reproduce it, all right? You did not replicate it, all right? Do you even science, bro?